So now let's look at Pascal's principle, which is basically, along the same lines as as what we're calling Pascal's law. Okay, and so I'll even make this kind of more pronounced, so that we have, say that we have some tube that's connected on both ends, but one end is much bigger than the other, and it's filled up with a fluid. Okay, so we have, force F being applied from the atmosphere on the top on both sides. Okay, and again, we're going to say that this is in static equilibrium. And so the question is, which side has a greater pressure? So is it going to be the left side or the right side? Okay. Well, what Pascal's principle tells us is that the pressure in is equal to the pressure out. So in other words, if we have a pressure on one side, we're going to have the exact same pressure on the other side. So this is going to say that it's the same on both sides. Which may be surprising, because let's think about this. We said that pressure is equal to force over area. And it would seem that this area on the right is much bigger than the area on the left. So how is it that we can say that both sides have the same pressure if the force being applied is from the atmosphere? Okay, and so this is something that's kind of subtle, and so we'll look at it. So let's kind of blow up the left side over here, and we'll blow up the right side over here. Okay, so now let's think about a column of air that's on top of this. Okay, so this column, if we were to look at all these air molecules right above us, is going to have some gravitational force down, right? But the pressure due to that column, right, is just going to be Fg divided by, basically the diameter of these little air molecules. Again, this is kind of a simplified picture, but I think this will help you understand why the pressure is going to be the same on both sides. Okay? Because now we think, oh, well, what if we have another column of air right next to that? And another column of air right next to that. Well, by, all I've done here is I'm saying the pressure is going to be 3 times F of G, because I have 3 times the mass on, because I have 3 columns. But then it's just going to be, divided by 3 times the diameter, because I have 3 rows of atoms. So it's still the same pressure. And so now, you can easily see that if I come over here, and even if I have a whole bunch of columns of air, it doesn't really matter, because I'm just going to divide by the number of columns anyway. So we see that on both sides we actually do have the same pressure. And so this idea that the pressure in is equal to the pressure out is Pascal's principle. This also explains why, if you have a container with toothpaste in it, why you can push it on the end, and then this pressure that you're putting on the end here ends up getting the toothpaste out. So you actually use Pascal's principle like every morning and every night when you brush your teeth. And so what does this mean? We can see that from Pascal's law, we know that the pressure is equal to P0 plus rho GH. So it's also telling us that the height on the left is equal to the height of the water on the right. Because if they have the same pressure, P0 is just the initial pressure that's above them. And so In both cases, it's going to be atmospheric pressure. So the water, or whatever fluid it is the same. It's the same fluid, so it's going to have the same density. And so the only variable left is the height, and so it means that the height must be the same.